Yo, thanks for being here. Um, I've been busy on the last weeks working on the timing and distribution sections of my engine, and I'm quite at a good point. So I thought that I needed some fresh air of the project and take note of what I learned so far. So this is basically a recap of what I found out. I have to say it was a lot since the last time I'd been, messing around with the whole bones constraints realm. But this time, I tried something different. I persisted a little more. I definitely took a little more than usual, and eventually I enjoyed the fun of gaining a notch here and there, if you know what I mean. So this is basically how I approach this. Before I do anything, I usually take my time to place some empties on the model because this will help a lot and speed up the process when we will be placing bones on the cam armature. Now, the engine has 4 valves per cylinder. This means 2 couple of valves each. These are the intake valves, the internal ones, and the external ones are the exhaust valves. So, since the elements of each couple move simultaneously, we don't need to rig each single valve. We can simplify our work with rigging just one of the couple and then parenting the other twin. So this is why I'm placing only 2 empties for each cylinder. Let's do a quick review of how the timing section of an engine works. We obviously know that each piston moves on a single axis, which is the z-axis here, the blue one. And so each piston goes alternatively in one direction and its opposite. So the top extreme of this travel is called the top dead center. So this is the highest point that the piston reaches on its path. And then when it goes down, this is the bottom dead center, which is the shortest distance from the piston to the crankshaft. So these two positions are key to better understand the timing diagram, like this one. So this is the top dead center and this is the bottom dead center. This is basically a diagram about the crankshaft revolution relative to the position of the piston. The blue line represents the opening phase of the intake valve, while the red line does the same for the exhaust valve. So these are the positions where each valve opens and closes relative to the crankshaft. And these orientations here are key to model correctly the animation of the valves. Now, if you're looking to do a basic animation, all you need to know is that in every engine, the intake valve opens somewhere before top dead center, and the exhaust valve opens somewhere before bottom dead center. You're looking at these 2 quadrants here. It's all you need to know, all you need to get a grasp on to do something credible, because this means that you can arbitrarily choose any 2 figures for that degrees angles and still get a credible animation. Just remember to keep those figures the same across each cylinder, because that is crucial to get a solid and enjoyable motion. And it all depends on the level of accuracy or obsession you're pushing. If you're an average serious case as I am, you might be encouraged to do some research and find the accurate timings of the engine you're modeling. So what we do is select the empty in front of the intake camshaft, put the cursor there, then select the armature, go into edit mode, and we add a single bone. Here it is. It's pretty big. Scale it down. Now, this will be the controller for the intake camshaft. So the intake camshaft will move accordingly to this bone, will be parented to this bone. We go into pose mode and we select our bone and switch this to Euler, the rotation to XYZ Euler, we have to see what angles are we in for the bone roll, and we go back to edit mode for that. So we see that each other bone has the X in this direction and the Z, which are not aligned with this new created bone. So we have to rotate to fix that to have a flawless animation, because having the bone rolls messed up could really bring trouble to your scenes and your animation. So you have to put that bones accordingly. So let's rotate that, not this way, let's turn to 70. Yeah, that will do. So we'll have to rotate the bone on the x-axis. So we switch back to pose mode. And now what we have to do is adding a driver between this bone and this bone. So this bone will be driven by this one. So to do that, we add a driver here on this X rotation, so we can see it's working. Well, actually, it's not working, but this is the axis we want to animate. And then we added the driver. And this will be based on the armature, and the bone will be the controller. And now they are in the very same position. But we don't want this to be based on the X location of the controller, but on its rotation. So we put that to rotation. And now we can see that already when the animation goes, these two bones are connected. They're moving. But we have to do adjustment to that. We have to edit back again, and we don't want this driver to rotate on the same direction, on the same orientation that the controller wants, because this is the crankshaft. This moves the crankshaft in one direction. But if we for a minute switch off the armature and switch on our belts, you can see that we already have the belts modeled on, and they are animated as well. If you make the animation go, you can see that the timing belts are rotating in the opposite direction of the crankshaft. So that means that we have to make this camshaft move in the opposite rotation verse of the crankshaft. To do that, we added our driver. We have already set X rotation, but we need to model this expression to be var, which is the value we are starting from, times minus 0.5. This way, we have the negative for the opposite sense of rotation, and 0.5 because in each engine, the camshaft rotates at half the speed of the crankshaft. But why is that so? Well, remember we talked about the top dead center and the bottom dead center. These are the two boundaries between each phase on the four-stroke engine. You know that we have the intake, the compression, the power, and exhaust phases. Each phase is separated from its next one by the crossing of those two boundaries between those two planes we saw before. So we know that the intake phase, which is the first one, begins at the top dead center, and you can see the piston is moving down, and it reaches the next phase, which is the compression, when it reaches the bottom dead center. So this is the first phase, and this is the first phase we are working on. So now that we are set, we have to find the position of the intake camshaft to align the cams accordingly to where they are supposed to be. So we have to set the camshaft accordingly to put the cam in position where the intake valve. So we know from our reference that the intake valve opens 14 degrees before top dead center. That's what we established from our documentations. If we play the animation and we followed our cylinder, this is the phase that we're interested in, this top dead center. So if we put our viewport display of the armature to sticks, it's easier to find that. So this is the top dead center where all these lines basically align and the piston reaches the top dead center. So we are about frame 69, I think, 76, 78, 68. 68 is our figure. So right now we have the controller rotation bone, which is at 408 degrees. So we have to put our cursor 14 degrees back from here. So we go back to, so we said 408 minus 14, that equals to 394, which is about here. Well, we said we'll do with 396. So this is the position where we need to be to in the moment where the intake valve opens. So to do that, to rotate our camshaft accordingly, we go back into object mode, still at this frame 66, and we rotate our camshaft to match the position where the valve are supposed to open, which is about here. Do something more. Let's try to reach the exact count, but which is overlapping already. Yeah. This is good. So we have to rotate the camshaft accordingly. Now let's apply the rotation. So we reset our new 0 to this position. And now we select back the armature. Let's put this back to octahedral. Better see them. Now we select the empty we placed before. We put the cursor there, and we go into edit mode, select the armature and go to edit mode. And then we add the new bone, which is always huge. We size him back to position, and then we need to find where to put the tail of the bone to better position it. So back to object mode, we select the camshaft, edit mode, and now we take this point here, which is the apex of the cam, and we put our cursor there. Back to object mode, select the armature, back to edit mode, and now we take the tail and try to, let's use this correct orientation, global is fine. And I'm making this manually because if let me show you something. If I just Shift S and selection of the cursor, you see that the bone roll is not anymore aligned with our scene, and we don't want that. Obviously we can switch back to edit mode and try to adjust the roll, but I found that a quicker way to do that is just by simply position the bone close enough to our interested point, and then only then put selection to cursor. This way the bone roll is not affected, and this is the correct position we're looking for. So this is where the cam is supposed to be when the intake valve opens. Now we have to constrain or set some constraints on this bone. So we go back to pose mode. First, let's just rename our bone we just created. So this is left intake cam bone 1, because we need 3 more of them. So we go to pose mode, and we had a bone constraint, not the normal constraint but the bone constraint. We had a child of constraint, and we target our armature and our intake camshaft bone. So this means that if we press play, now the bones will move together. So this bone will follow this one. And that's what we want. Back to frame 66 where they are supposed to be. Yeah, all right. So at this point, we can parent our camshaft to the armature, because right now we set our first common point where we are in the right position to do so. To do that, we select the camshaft first, shift click on the armature, then we go to pose mode, and we already have the bone we need selected. So we just have to do Ctrl P, set parent to bone. If we now select play, you see that our rig is working accordingly. So the cam bone is going in the opposite way of the crankshaft, and these are aligned with the same speed of rotation. So we go back to our frame 66, and now we can parent our bone. We can parent our bone to the armature. So we select the camshaft, we select the armature, we switch to pose mode, we select our bone, and we can press Ctrl P and set the parent to the bone. Now if we press play, the camshaft is moving together with the bone, together with the armature. All right, back to our frame. Now it's time to rig the actual valve. So this is where the fun begins. We now have to put our new bone on the armature to match the actual valve. So let's hide the armature for a second, and let's place our empties where needed. We go back to object mode, we select our valve, and we go to edit mode, isolate the valve, and this is where we want the bone to start. So Shift S, cursor to selection, back to object mode, we bring back the model, the entire model on, we take the armature back and select the armature, go to edit mode, Shift A, and we add a new bone. All right, let's fix the axis before we do anything else, so we get rid of this problem from the beginning. -90. Oops, that was not what was intended. 90. Let's put a minus. Yeah, so this is big enough to see. Now we select our tail, scale it back, and we try to put this in position near the bottom of the valve. To be more precise, we select the valve back again. We select our inner point here, cursor to selection, back to object mode, select the armature back. We had the tail already selected, so when we are close enough, we just do Shift S, selection to cursor, and now it's in position. And we'll call this left intake valve 1. All right, and this is our, first element of the valve to put on. Let's just try to animate this. We go to pose mode, select our new created bone, the intake valve bone, and we go to the bone constraints panel, and we need 3 constraints here. The first one is limit rotation. We check all the boxes, and we put the owner to local space. So this is the first we have to set. Then we put a limit location, and again we select everything. The bone goes crazy again, but you select local space and it will snap back into position. So the only movement that the cam will be able to do, the valve will be able to do, is some millimeters in this direction. So I'll start with I don't know, 12 millimeters maybe. Obviously, if you do know this data, it's easier, but we just have to gauge our way along as we go. This means that this bone will only move on the y-axis on an excursion of 12 millimeters. The last constraint that we need to add to our scene is the limit distance constraint. We have to put it on top of the list. This is very important, otherwise it will not work. We target the armature and specifically the intake cam bone. We set the head tail to 1. We set the clamp region outside, and we have to set the distance. It comes with a preset distance already calculated on I don't know what, but you need to reduce that. And you see why in a minute. So we can see it's already working. The movement is already working, but we need to reduce this distance to set to be as close as possible to the valve, because this distance measures how close this point here needs to be to this one to affect its movement. This depends really on your scene, because you have to set it up when you parent your bones to the actual objects that they're gonna be affected by the movement. So let's switch back to sticks, which let us to see clearer what I mean with that. Let's put this back to frame 66, and now we have to select the object that will be driven by our new made bone. So this is the shim, this is the valve. So to parent our bone, we have to select the parts affected. So I have this shimmer up here, this other one inside the valve, and the valve itself. All these 3 will be parented to the valve bone. So we select these, and we select our armature. We go to pose mode, we select the valve bone, Control P, parent to bone, and now the valve is moving with a camshaft. And now we can fine tune our value. We can see that we are overlapping a little, so this means that our value needs to go a little higher than that, so maybe 8 millimeters. Let's see, but it needs to start a little sooner. It's a little better, but not enough. It's close, so let's put 10, and this goes way too down. So if this is the case, we need to find a sweet spot between that and the length of our bone. So we have to go back to frame 66, go to edit mode, and we have to move I don't know if I have the right orientation here. I will fix that. let's select this one, normal, and now we have the correct orientation, so we put this one. So back to edit mode, and we put this position with this bone something around here, something lower than that. Back to object mode, pose mode, and let's see what happens. Now it's not affected. So we can set our distance something higher than that, maybe 11. And now it's going a little better. So you obviously can't, this means that you obviously can't, you know, find the right position, but let's try with let's put this back into position. Let's try with 13. And now it's pretty much, it's almost there. So back to edit mode, maybe put this a little lower. Back to pose mode, let's see what happens. And yeah, you get the picture. It's really a matter of gauging the right spot. It all depends on how hard you can go with the regulations, but it's a sweet spot between the actual starting point of the bone here, of the valve bone, and the distance you set into the limit distance constraint. So you can fine-tune that. After we do that, the next step is to add the animation for the springs. This particular engine has valves with 2 springs for each valve. We have the inner spring here, and we have the outer spring there. So they both will be constrained to a bone. To do that, we just have to select the start of our compression. So it's around here. We put our cursor there, and we go back to object mode. We select our armature, edit mode, right? And we set a new bone, which is Shift A. We are back to sticks. So let's make it octahedral and reselect our global orientation. And now we have to put this in position. Let's go back to sticks. And we want this bone to reach, let's say, this place here. So we select the armature back again, edit mode, and then we just set our bone into position. Let's see if the roll is correct. Looks like it. No, it's not. Back to edit mode, select this one. As you can see, the X is not aligned with the others. So let's add, well, let's subtract 90 degrees. All right, now it's correctly orientated. So we shift click, we click on this bone, we name it to left intake spring 1. So now we select our spring bone, and we shift select the valve bone, and we press Ctrl P, and we select keep offset. So in this way, if we go to pose mode and we play the animation, you see that the new bone follows the valve bone. Back to 66. The last thing we need to do is put a base to this bone to stretch to. So we go to edit mode again. We already have this place, which is perfect, selected. Shift A, new bone. We scale it back, and this doesn't need to be particularly orientated in any direction. It just needs to be there at the end of the previous bone, and we call this left intake phase 1. The purpose of this little bone is just to be able to select our spring bone, go back to pose mode, add a constraint which will be stretched to. We select our armature. If we this is easier to search here, armature, and then we select our bone. This is why it's good to name our bones. We set it L intake base 1. All right, and we'll put maintain volume to none, so the valve won't, you know, become funny when they compress. If we play now the animation, we will see that the spring bone is compressing, but it's not overreaching the spot. So this is what the stretch to constraint does. So we stop the animation, put back to frame 66. We go back to object mode. We select our valves together. Then we select the armature. Go back to pose mode. And you can see that we have the valve bone, the spring bone, sorry, already selected. So we press Ctrl P and we set parent bone. All right. And now, if we have done everything correctly, let's hide the armature. You can see that the bone, you can see that the valve is working correctly. So what we have to do now, we just have to parent similar objects together so that they move accordingly and simultaneously. So springs, this shim here, this is need to be placed, but this is just for example. This part is not moving, so we will animate it, and the valve. And now, boom, we're in business. Step is to model the same thing on the exhaust camshaft, which is this one. So first of all, we need to set a new bone for this camshaft. So we switch to edit mode. Well, first of all, let's put our cursor here, cursor to selection, right? We select our armature, edit mode, Shift A to add a new bone, scale it back. Doesn't really matter how big it is, but we want to be similar to the other one. We go to switch to edit mode to set the right roll. So let's put it 90 minus, all right. And then we just have to put the same driver we have here. So we just copy the driver and paste it, switch to Euler and right click, paste driver. So these two bones will be having the same orientation, the same rotation. And this is crucial for the camshaft because this is how they are supposed to work. Right, so the next step is to find the position of the exhaust valve opening. And so we go back to selecting the controller bone because we need this figure here. And we slide the animation so the intake valve opens, piston goes down. Now it's coming up. This is the intake phase. The intake phase finishes here, and then the piston is coming back. So this is the compression. Now we have the combustion here. Pistons goes down. And we are back. It's traveling to its bottom. So back into pose mode. We see that this is the bottom dead center, right? So before we reach that, we need to be 54 degrees subtracted to this figure here. So 9048 minus 54 equals 896, if I'm staying corrected. So we go back to 896 and we can see that our frame goes to 894 to 900. So we have to adapt to the figure the closer we can get. So 894 is fine. We are at frame 149. So this is where the exhaust valves will open. And it looks like we are a bit lucky because our valves looks like they are already in the perfect position. Maybe because this is how I left them before removed the armature for this tutorial. So we are already in position here. From now on, we have to reply what we did here, the exact same procedure. So these bones will be added. So we need to add a new cam bone, which will be the exhaust one. We select our empty, we put the cursor there, and this is like what we did before. From now on, we have to do exactly the same thing that we did here. So we select our empty, cursor to selection, we select our armature, we go to edit mode, add the new bone, let's just rotate it already, so -90, and then we put this in position and we try to move it more or less where it's supposed to be, and then we'll fine tune it. So we select object mode, select the camshaft. This is the point, cursor to selection, back to object mode. So we select the armature back, edit mode, and then we approximate our position the closest way possible, and then we press Shift S, selection to cursor. And now our bone, which we'll rename L exhaust cam 1, and then we go to pose mode, select this one, and we put a bone constraint child of, target the armature, and we target this bone. So now we can see even the exhaust bones are working accordingly. So we were at 149 frame, we go back there, and object mode, we select the camshaft, we select the armature, pose mode, Control P, parent to bone. So now also the exhaust camshaft is rigged. We select our valve actually to gain some time, our new created bone where it needs to be. So we use the shim for, as we said before, our starting point from the new bone. Object mode, we select the armature, edit mode, Shift A, new bone, and we do basically what we did on the intake valves. And this is it. So from now on, you just have to replicate, move the crankshaft accordingly along this path and reply this to every single other cylinder. It's a long process, but you need to have some patience with that. So if you made it this far, thanks a lot for watching, and I'll see you on the next one.